Hi there, this is Mr. Alexander, and today I'm here to talk to you about the quadratic formula. But before I do that, I wanted to show you something real quick here. We've been talking about quadratics and how to solve them. If I go to y equals here, and I just typed in a simple quadratic function, x squared minus 4, and I hit the graph button, what we're doing when we're solving quadratics is we're simply trying to figure out where this thing crosses the x-axis. Now, this thing has two solutions because it crosses the x-axis twice, and they appear to be x equals -2 and x equals +2. To confirm that, if you go to the table, you can see at -2, y equals 0, and at +2 equals 0. So indeed, this thing does have two solutions, and they are at -2 and at +2, because it's where y equals 0 or where it crosses the x-axis. Now, if I change the equation a little bit and I just make it x squared and then I graph it, this thing has one solution because it crosses the x-axis only one time, and it appears to be at 0, 0. But let's double check. Yeah, 0, 0 is the one solution to this quadratic x squared. I'm going to change the equation one more time. Make it x squared plus 4. If I graph this one, it never crosses the x-axis. So it would appear that this thing has no solutions. Well, that's only half right. That's only the half of it. This thing has no real solutions. The solutions are not real numbers. It actually does have two solutions, but they are complex numbers. And to find those complex numbers, we need to use something that's not a calculator, because the calculator is not real great dealing with complex numbers. The thing that we're going to use is the quadratic formula, which, if you don't remember, is x equals -b plus and minus the square root of b squared minus 4ac, all divided by 2a. So what we're going to do is we're just going to use this equation 4 or 5 times, and we're going to first identify how many roots this thing has, how many solutions it has, and what type they are, and then I'm going to solve it. So if I type in this equation that I've got, y equals -x squared minus 5x plus 6, and I graph it, I can see that this thing has two solutions, and there are two real solutions, meaning the solutions are real numbers. So as I'm using the quadratic formula, I know that my answer should be, I should get two answers, and both of them should be real numbers, meaning there's no i's in the answer. So I'm going to just plug stuff in. First thing I like to do is identify the a, the b, and the c. In this case, the a is right there in front of the x squared, that's -1, the b is -5, and the c is 6. So, as I'm going through here, I'm going to just plug that information into the quadratic formula. X equals, the first thing you ought to do, you can't solve a quadratic unless it's set equal to 0. So plug in for y, plug in a 0 for y. So we're going to say 0 equals -x squared minus 5x plus 6. That's an important step, because we can't solve it unless we say, well, it's equal to 0. All right, so x equals -b, so a -5 is +5, plus and minus the square root of b squared, -5 squared is 25, minus 4 times a, which is -1, times c, which is 6. All divided by 2 times a. 2 times a is -2. Well, if I simplify this a bit, -4 times -1, well, that's +4, times 6 is 24. So this is 25 plus 24, which is 49. So this is 5 plus and minus the square root of 49, all divided by -2. Okay? Well, the square root of 49 is simply 7. So x equals 5 plus and minus 7, all divided by -2. Well, we can work that out now. We can say, all right, 5 minus 7 is -2. -2 divided by -2 is just 1. And then 5 plus 7 is 12. 12 divided by negative 2 is negative 6. So my two solutions are x equals 1 and x equals negative 6. Now you might have noticed that when I graphed it. Negative 6, positive 1. So sometimes we don't even really need the quadratic formula to see the solutions. But when it gets a little more complicated and we can't see it on the graph, that's when we need the quadratic formula. But in this case, we didn't really need it. Let's see if we need it on the next one, though. 3x squared minus 4x minus 1. I'm going to go ahead and graph that just to make sure that I do need to use the quadratic formula. Maybe I don't. 3x squared minus 4x minus 1. Graph. Well, I think it's obvious that this thing has two solutions, and they're two real solutions, meaning the answers are going to be real numbers. And it's not clear where they cross. I'm going to look at the table, and I'm looking at for zeros in the y column, and I'm not seeing any, which means that I need to use the quadratic formula because the answer is not going to be a whole number. It's going to be a decimal answer, and we want the exact answer. I'm going to show you how to find that exact answer. All right, so let's just set this thing equal to 0 so that we can say, all right, well then a equals 3, b equals negative 4, c equals negative 1. And we're just going to plug everything we've got into the quadratic formula. So x equals negative b, which is positive 4, plus and minus the square root of negative 4 squared minus 4 times 3 times negative 1. All divided by 2 times a, which is 2 times 3, which is 6. All right. 4 times 3 is 12. That's going to become a negative 12. So a negative and negative is a positive. So this is 16 plus 12, which is 28. So this is 4 plus and minus the square root of 28, all divided by 6. Now you might be inclined to stop right there because that's an exact answer, but we can simplify this thing further because the square root of 28 can be written a different way. Here's the way I like to check it, though. This little calculator trick. If we do 28 divided by x squared, and we go to the table here, and we scroll down to the first y value that's less than 1, and then go up to the first set of whole numbers for x and y, I got a 2 and a 7. Which means the square root of 28 is the same as 2 root 7. Let me prove it to you. Square root of 28, big nasty number. 2 root 7, big nasty number, but it's the same number. So this second one is the one we want to write down. So we're going to write this as x equals 4 plus and minus 2 root 7, all divided by 6. You might be inclined to say you're done there, but you'll notice that 4, 2, and 6 are all divisible by 2. So let's divide all three of those by 2 to get 2 plus and minus 1 root 7, or just root 7, all divided by 6. I'm sorry, 3. Whoops. Now this is the exact answer, so it is the answer. But if you wanted to be a little bit more specific, you could say, well, this is actually 2 over 3 minus root 7 over 3. That's a 7, not a 3. Comma, 2 over 3 plus root 7 over 3. And that's also an acceptable way to write the answer if you didn't like that plus and minus. And you just need to distribute the 3 to both. Break it into two fractions. But generally, when you see it written, you're going to see it written this way. Okay, let's take a look at another one. Fairly simple looking one. Let's graph it and see what's going on here. Y equals x squared plus x plus 1. When I graph it, I can see that this thing never crosses the x-axis, which means I'm going to have two complex solutions, which means we're going to have an I in there. We're going to have some imaginary numbers going on. But let's set it equal to 0. A equals 1, B equals 1, C equals 1. Looks simple. Maybe it is simple. Let's find out. X equals negative B, which is negative 1, plus and minus the square root of 1 squared, which is just 1, minus 4 times a times c, all divided by 2a, which is 2 times 1, which is just 2. 4 times 1 is just 4. So this is 1 minus 4, which is the square root of negative 3 divided by 2. Uh-oh. Well, we don't like that square root under there. All that means is this is an imaginary number. Specifically, that's I root 3. So the square root of 1 comes out and goes to the front of the square root and becomes an imaginary. So this is the answer. This is as simplified as it can get. But if you wanted to rewrite it this way, negative 1/2 minus root 3 I root 3 divided by 2, comma, negative 1/2 plus I root 3 divided by 2. So 2 ways you could write that. This is more condensed. This is listing out both the solutions. Now that might not feel very satisfying because there's an I in there, some fractions, but this is the exact answer, and this is the way that we're going to expect you to write it. But the reason it's not satisfying is because look at the graph. It never crosses the x-axis, so that's why we had complex solutions. And that's going to happen on occasion. All right, let's do this one last. 2x squared plus 7x plus 13. All right, so let's just type that in. 2x squared plus 7x minus 13. And let's see what we get when we graph this thing. Looks like 1, 2 real solutions. So we know we're going to get 2 real numbers. Let's figure out what they are. Set it equal to 0, so we know we're solving. Say a equals 2, b equals 7, c equals negative 13. And once again, we're just going to plug stuff directly into the quadratic formula. X equals negative b, which is negative 7, plus and minus the square root of b squared, which is 49, minus 4 times a, which is 2, times c, which is negative 13. All divided by 2a, which is 2 times 2, which is 4. All right. Let's simplify underneath the radical there. 4 times 2 is 8. 8 times 13 is 104. So now I'm dealing with 49 plus 104. And that ugly number is 153. So I'm going to have negative 7 plus and minus the square root of 153 divided by 4. Now, we can simplify that square root a little bit. 153 is kind of a monster, but I've already shown you the way to cheat a little bit and find out what that square root is. So if we do 153 divided by x squared, go in the table here, scroll down to the first one that's less than 1 in the y column, then go back up until you see a whole number in the x, a whole number in the y. There it is right there, 3 root 17. That's how I'm going to simplify this thing. So this is negative 7 plus and minus 3 root 17 divided by 4. Well, is it simplified as far as it can be simplified? Negative 7, 3, and 4 are not, they don't have a common factor, so it's completely done. So you can write it this way, and it's correct, or you could write negative 7 over 4 minus 3 over 4 root 17, comma, negative 7 over 4 plus 3 over 4 root 17. Either of those answers is acceptable, and that, ladies and gentlemen, is the quadratic formula. Thank you for watching. Hope it's been useful, and we'll see you next time.